Hello everyone, welcome to this video where we'll explore a fundamental aspect of working with PySpark, how to show the schema of a data frame in PySpark. Understanding the schema of your data frame is crucial for working effectively with big data. The schema defines the structure of your data, including column names, data types, and whether null values are allowed. In this video, we'll cover multiple methods to view and interact with the schema, helping you choose the best approach for your specific needs. Let's dive in and explore the different ways to inspect the schema in PySpark. Introduction. In PySpark, the schema of a data frame defines its structure, including column names, data types, and whether columns allow null values. Understanding the schema is essential for ensuring data consistency and optimizing data processing workflows. PySpark provides methods like printSchema to display the schema in a tree-like format, making it easy to verify the structure of your data frame. These tools are invaluable for working with large data sets, helping you analyze the structure at a glance and ensuring compatibility with your analysis or transformations. Ways to show a data frame in PySpark using multiple methods. 1. Using printSchema. The printSchema method in PySpark provides a simple way to view the structure of a data frame in a clear, tree-like format. It displays the column names, data types, and nullable constraints, making it easy to understand the schema at a glance. This method is especially useful for verifying the structure of large or complex datasets, ensuring that the data frame is correctly defined before applying transformations or analysis. It's a quick and effective tool for inspecting your data schema in PySpark. Practical example. This example demonstrates how to use the printSchema method in PySpark to display the schema of a data frame. The schema reveals the structure of the data frame, including column names, data types, and nullable constraints. Let's go through the steps in detail. Step 1. Initialize Spark session. The process begins with the initialization of a Spark session, which is the entry point for all PySpark applications. The builder.appName shows schema example method assigns a name to the session, and getOrCreate creates a new session or retrieves an existing one. This session serves as the environment for creating and managing data frames. Step 2. Create a data frame. A list of tuples is used to define the sample data. Each tuple represents a record containing the following fields: ID, unique identifier for each record; name, the name of the employee; department, the department in which the employee works; salary, the employee's salary. The created data frame method is called with the data and column names to construct the data frame. In this example, the columns are named ID, name, department, and salary. The resulting data frame organizes the data in a tabular format with each tuple corresponding to a row. Step 3. Show the schema. The printSchema method is used to display the schema of the data frame. This method outputs the column names, their data types, and whether they allow null values in a tree-like format. For the provided data, the Idaho column is inferred as an integer long type. The name and department columns are inferred as string type. The salary column is inferred as an integer long type. The output confirms the structure of the data frame, helping you verify that the data types are correctly interpreted and aligned with your expectations. By using printSchema, you gain valuable insight into the structure of your data frame, enabling you to proceed confidently with data processing and analysis tasks in PySpark. 2. Using schema attribute. The schema attribute in PySpark allows you to access the schema of a data frame as a struct type object, providing a detailed view of each column's metadata. Unlike printSchema, which displays the schema in a tree-like format, The schema attribute returns a programmatically accessible object. This includes information like column names, data types, and nullable constraints, which can be used in code to validate, manipulate, or transform the schema dynamically. It's a powerful tool for programmatic schema inspection in PySpark. Practical example. The This example illustrates how to use the schema attribute in PySpark to programmatically access the schema of a data frame as a struct type object. This method is particularly useful for inspecting and manipulating a data frame structure in detail. Let's break down the steps. Step 1. Initialize Spark session. The process begins with the initialization of a Spark session, which acts as the entry point for PySpark operations. The session is named schema example using builder.appname and created using git.create. This session provides the environment for defining and working with data frames. Step 2. Define a sample data frame. Sample data is defined as a list of tuples where each tuple represents a record. 1. Alice HR 5000 represents an employee with ID 1, name Alice, department HR, and salary 5000. Similarly, records for Bob and Charlie are included. The column names are defined as a list ID, name, department, salary. This data and column definition are passed to the created data frame method, which converts them into a structured PySpark data frame. Step 3. Access the schema using the schema attribute. The schema attribute is used to retrieve the schema of the data frame as a struct type object. This object contains detailed metadata for each column, such as column name, data type e.g. string type, integer type, nullable constraint, whether the column allows null values. When printed, the struct type schema provides a comprehensive representation of the data frame structure. Step 4. Programmatic access to schema fields. The schema's detailed information can be accessed programmatically by iterating through its fields. Each field is a struct field object, which includes attributes like name, data type TP, and nullable. For example, uh, the Idaho column is of type integer type and allows null values. The name column is of type string type and also allows null values. This programmatic access enables dynamic schema validation or transformation, making it a powerful tool for advanced workflows. This example demonstrates the flexibility and power of using the schema attribute in PySpark, enabling detailed inspection and dynamic manipulation of data frame schemas in distributed data processing workflows. 3. Using the types attribute. The types attribute in PySpark provides a quick and concise way to view the column names and their corresponding data types in a data frame. It returns the schema as a list of tuples, where each tuple contains the column name and its data type. This method is especially useful for scenarios where you need a simple, programmatically accessible representation of the schema without the additional details provided by the schema attribute. It's a lightweight and efficient way to inspect or validate the structure of a data frame in PySpark. Practical example. This example demonstrates how to use the types attribute in PySpark to retrieve the column names and their data types from a data frame. The types attribute provides a simple, programmatically accessible representation of the data frame schema returned as a list of tuples where each tuple contains the column name and its data type. Let's walk through the steps in detail. Step 1. Initialize Spark session. A Spark session is initialized using the Spark session.builder method. The session is named dtypes example to make it identifiable, and the get.create method creates or retrieves the session. This Spark session serves as the entry point for working with data frames in PySpark. Step 2. Define a sample data frame. The sample data is defined as a list of tuples where each tuple represents a record. 1. Alice HR 5000 contains an ID, name, department, and salary for the first record. Similarly, the subsequent records represent Bob and Charlie. The column names are defined as a list ID, name, department, salary. This data and column definition are passed to the created data frame method to construct a structured data frame. Step 3. Access the column data types using the types. The types attribute is used to retrieve the schema of the data frame as a list of tuples. Each tuple contains the column name and its data type. For example, the Idaho column has a data type of begin mapped to long type in PySpark. The name and department columns are of type string. The salary column is also of type begin. The dtypes attribute provides a simplified view of the schema compared to schema or printSchema, focusing solely on column names and data types. The schema is printed by iterating over the list of tuples and formatting the output for clarity. His example highlights the utility of the types attribute as a quick and efficient tool for schema inspection in PySpark, making it a valuable addition to your data processing toolkit. 4. Using SQL describe. Using the SQL describe command in PySpark provides an alternative way to view the schema of a data frame by first registering the data frame as a temporary SQL table. You can leverage SQL commands to inspect its structure. The describe command shows column names, data types, and other metadata in a tabular format, similar to SQL databases. This method is particularly useful for users familiar with SQL or when working in environments where SQL queries are integrated with PySpark workflows. It's a flexible approach for schema inspection when combining SQL and PySpark operations. Practical example. This example demonstrates how to use the SQL describe command in PySpark to view the schema of a data frame by first registering it as a temporary SQL table. This method integrates PySpark with SQL queries, providing an alternative and intuitive way to inspect the structure of a data frame. Let's go through the steps in detail. Step 1. Initialize Spark session. The process begins with the initialization of a Spark session, the entry point for working with data frames in PySpark. The session is named descriptable example using the builder.appName method, and getOrCreate ensures that the session is created or retrieved. This setup allows PySpark to manage and execute SQL queries on data frames. Step 2. Define a sample data frame. The sample data is represented as a list of tuples where each tuple contains ID, unique identifier for each record, name, the name of the employee, department, the department to which the employee belongs, salary, the salary of the employee. The column names are defined as a list ID, name, department, salary. Using the created data frame method, the data is converted into a structured PySpark data frame. Step 3. Register the data frame as a temporary SQL view. The data frame is registered as a temporary SQL view using the created replace temp view method. The name employees is assigned to the view, allowing the data frame to be queried like a SQL table. This step enables the integration of PySpark with SQL, making it easy to leverage QL commands for analysis. Step 4. Use SQL describe command to view schema. The describe command is executed using the spark.sql method to retrieve the schema of the employees table. The output displays the column names, their data types, and nullable constraints in a tabular format. ID integer type. name string type, department string type, salary integer type. This SQL-based approach is especially useful for users familiar with SQL workflows or when SQL-based reporting and analysis tools are integrated into the pipeline. Step 5. Perform SQL query on the data frame. To validate the contents of the table, a SQL query select from employees is executed using the spark.sql method. The query retrieves all rows and columns from the employees table, displaying the data in a tabular format. This step confirms the integration of the data frame with SQL and demonstrates how SQL commands can be used for querying the data. By leveraging SQL commands like describe, you can effectively inspect and interact with PySpark data frames in a way that integrates seamlessly with traditional SQL workflows. 5. Detailed comparison of schema viewing methods. PySpark offers multiple methods to inspect the schema of a data frame, each catering to different use cases and preferences. Here's a detailed explanation of each method, its description, and when to use it. 1. Print schema. The print schema method displays the schema of a data frame in a tree-like format. It provides a human-readable representation of the column names, their data types, and nullable constraints. This method is ideal for quickly understanding the structure of a data frame, especially when dealing with nested or hierarchical schemas. It's commonly used for a visual inspection of the schema during data exploration or code debugging. Use case when you need a quick overview of the data frame structure in a readable format. 2. Schema attribute. The schema attribute returns the schema of a data frame as a struct type object, which contains detailed metadata for each column. This metadata includes the column name, data type, and nullable constraints, making it suitable for programmatic schema access and manipulation. Developers can iterate over the struct field objects within the struct type to validate or dynamically transform the schema. Use case when programmatic access to schema details is required for dynamic validation or transformation workflows. 3. The types attribute. The types attribute provides a concise representation of the schema as a list of tuples, where each tuple contains the column name and its data type. This method is efficient for scenarios where you only need to validate or inspect column names and their types without additional metadata. It's lightweight and can be easily integrated into automated validation or debugging scripts. Use case when you need a simple and concise view of column names and their data types for quick validation or debugging. 4. SQL describe command. The SQL describe command allows users to view the schema by registering a data frame as a temporary SQL view and executing a SQL query. It displays column names, data types, and nullable constraints in a tabular format, resembling the output of SQL database systems. This method is particularly beneficial for SQL users or workflows that heavily integrate PySpark with SQL queries. Use case ideal for users familiar with SQL or when working in hybrid environments where SQL and PySpark are used together. And that's a wrap on the various ways to show the schema of a data frame in PySpark. Whether you're using printSchema for a quick overview, the schema or types attributes for programmatic access, or the SQL describe command for SQL-based workflows, PySpark provides versatile tools for inspecting your data structure. Understanding and utilizing these methods is essential for effective data processing and analysis. If you found this video helpful, don't forget to like, share, and subscribe for more insights on PySpark and big data workflows. Thanks for watching and see you in the next video.